to restate what I just did, I drew two triangles that said that they were similar to each other because I just started my recording. And in doing that, I drew them like they were congruent because I don't know enough about which one's bigger than the other one. I just want to make sure that the vertices correspond. So A goes with D, B goes with E, C goes with F. So now I'm going to switch back to my problem so we can look at that. And let's see what we have. All right, so we're here, maybe. Nope, that's not it. You go away. All right, so I am looking at, now I have those two things that are similar to each other. Now I have to start labeling. BC is 4, EF is 12, and they have perimeter and area that they've given to you. Okay, so I'm going to write these on my page right now and label what I have. And they're all millimeters, which is great because I don't have to convert anything. But what I have enough of is information to be able to kind of set some of these things up if I need to. In fact, what I really do enjoy is when they're talking about this, they're saying, okay, well, we've got this is the perimeter, and then this is the area. And you just have to make sure that you're doing the right one. So I know that the perimeter is 42. I know that the area is 96. And those are the perimeter and the area of DEF. Just make sure that you've got them labeled correctly because sometimes it's hard to know what it is that you're looking for. And so what I'm going to do now is switch us back so you guys can see everything that I have done on the camera. This is the other thing that I've learned to do this year is to talk a whole lot while I'm doing things. So right now, I labeled the two sides, 4 and 12. I know the perimeter and the area of the second shape. Now I need to find the perimeter and the area of this shape, okay? And I will absolutely share the slides after class because this one's almost done, so we should be in pretty good shape here. Okay, so here's my question. To you guys, do you recall, am I able to do perimeter and area the same way when we set these things up? Do you remember this? I see somebody privately said no with a question mark. Maybe says maybe with a question mark. You ask very good. Like, I like that your lack of confidence, but your willingness to be able to participate is actually important. So here's what you have to think about. Perimeter is just a linear distance. So perimeter of any of these is just the distance around the outside of it, which means the relationship between these two, this proportional relationship between these two corresponding sides, is the same as the relationship of the perimeter because I'm just adding together all of the sides. So perimeter to perimeter will be the same as length of side to length of side. So I can just use the 4 and the 12 for that. Because when we deal with the area, we're actually multiplying two values together. It's base times a height. In this case, I have to square that relationship to be able to compare it to the area comparison to make that work. So perimeter is just the regular, we'll call it A to B. The area is A squared to B squared when we're doing this. So let's set this up so that we can see it. First, let me do the perimeter the way that we need to. I'm going to go, or not the perimeter, but the proportion between the two. So let's go 4 to 12. We'll go small triangle to large triangle. And as I set that up, we're going to just do our proportion. Wow, that's the worst writing ever. This right here, this is what you missed out on this year. That's the way that everything is written, always. So it was 4 to 12 for small to large. Can you guys reduce that for me and tell me what that is? 4 to 12 reduces to what? 1 to 3. Okay, so 1 to 3 is our base ratio. And that is I guess the top one is that's our ABC, and the bottom one is our DEF. Okay, so far, so good. We're dealing with just sort of the relationship between the linear lengths are going to be 1 to 3. Now, that's this one to this one. We don't know our perimeter for this one, but we do know our perimeter here. So if I'm going to set up a proportion to solve it, what I can say is that the perimeter of ABC over 42 is equal to 1 to 3. You guys kind of with me in terms of how I set that up? Because this is small to large, this is small to large, so I can set this up as a proportion. Now, all I got to do is cross multiply. 42 times 1 and P times 3. So I'm going to get 3P equals 42. And then if I take both sides and divide them by 3, this will cross out, and I will get that the perimeter of ABC is equal to 42 over 3, which is 14. 14 is our perimeter, and we can do this in millimeters because that's what it said, of our smaller triangle. Okay, so here's what I want you to do. Guys, with what I just did for that, everybody cool with that general idea? Y'all good with this? Okay, so let me go back up and make that label. I just solved this one. So let's go up here. I'm going to make this 14 millimeters. We are one step down. Now we got to do the area. When we do area to area, this is what we have to do. Where does the 3 next to the P come from? So when we set this up, we had reduced our base ratio and we cross multiplied. So it was 42 times 1 and 3 times P once I set these up. That's where it came from. So the 3P came from 3 times P. Cool? You good, Will? All right, cool. Now, let's think about what's going to have to happen then if we're going to be talking about the area proportion or the area ratio. I'm going to take my base ratio that we have right here. Why is the P on the bottom crossed out too? I'm trying to see. Why is there a P on the bottom crossed out? It's not. The 3 is there crossed out. There shouldn't be crossed out P's, should there? My writing is terrible. Just stay with me for this. Let's do the area ratio, and then we're going to do more of these in a minute. We take our base ratio, this 1 to 3, and what we have to do is take the whole fraction and square it. So top times top and bottom times bottom. 1 times 1 will be 1. That one's pretty easy. 3 times 3 will be 9. So our area ratio that we're going to be comparing is 1 to 9 in this case, this being ABC and this being DEF. Now, listen to me when I say this to you. You could absolutely have taken this 4 to 12, squared the top and squared the bottom, and you could use that to do the comparison of what we're doing. It would be 16 over 144. Totally fine. If that is what you would like to do, it's totally fine. What I'm saying to you is that this is going to be something that as we do this work, sometimes it takes a little bit longer for us to kind of figure this stuff out. I just wanted to make sure that you recognize reducing this is the easiest way to work through it when we're doing this stuff. Everybody cool so far? You guys good? All right, cool. So here's what we're going to do. This 1 to 9 is my area ratio. The area that I know from the original problem. Oh, why is this P crossed out? Is that what you were talking about before? Matthew, you asked me, why is there a P crossed out? It's because I wrote this wrong on the page and I needed a space because I was using a different color. Okay, so now we know that the area of the larger one is 96. We're trying to find the area of the smaller one. So I'm going to take this fraction here and I'm going to set it up next to another fraction, which is going to be our area of ABC. We don't know. We know that 96 is the area of the DEF. So now what I have to do with something like this is cross multiply. All right, you ready? Everybody ready to cross multiply? Yup. Okay, here we go. 9 times A, 1 times 96. This is actually pretty easier for us to do. So we will get that 9A is equal to 96. Then what will we do? Divide both sides by 9. And I'm going to get that the area of the smaller one is equal to 96 over 9, which is going to be a fraction. If I'm remembering correctly, it is going to be 10 2/3, if I'm remembering right. Is that 96 divided by 9? Yeah, I think that's right. Okay, 10 2/3 is what I'm going to be getting for this one. So, or 10.6 repeating. And that is millimeters squared. Now, what I need you to recognize when we're starting to talk about some of these, we're going to get answers when we talk about area that are not going to be nice, happy whole numbers all the time, because we're not talking about, the perimeter is nice. You're just adding 3 sides or 5 sides if you're talking about a pentagon. When we're talking about the area, because you're going to be multiplying things that are going to have to be proportional, it isn't always going to be nice. This is okay. I mean, the numbers aren't going to be difficult for us to deal with, but I want you to recognize that it's okay to get an answer like that as long as we checked all of our math. This is one of the reasons, though, that you really want to share your work so that I can see if you have made a mistake somewhere. I can say, okay, when we're looking at this, we got 10 2/3 millimeters squared. And in your head, you're thinking, is this right? It's 100% right. But what's going to really let me know is that I see you did this to get here. You compared the correct 2 fractions. You cross multiplied. You got your answers. And I see what you divided by to get to them. You're good. If you made a mistake here someplace, but all of your process is correct, you're going to get most of the credit. It's just going to be, I can say, oh, the mistake you made is that when you squared this, you did a 6 instead of a 9. So I guess you just multiplied by 2. Easy mistake to make, but that messed up your math. And so our answers are different. See, guys, that's what we got to do. Okay. Does anybody have any questions about this specific problem before I move on with what we're going to do here? I'm going to share back at the slides and let you guys ask anything that you're going to need for a minute. Come on now. There we go. We're back here. Okay, so Will, you said you're sort of lost. And what I think we can probably do, we're going to go through some more problems with this. But ultimately, what we're looking at is this, come on now, this general idea that if you've got two similar figures, the similarity ratio between the two shapes is going to be the same as the perimeter ratio. So if you're comparing the perimeters of two similar figures, you can set up proportions with this fraction equal to this fraction and cross multiply. If you're doing it with area, you square the similarity ratio and use that as your base of comparison. We're going to do a couple more and it should be fine. But what I want you to do, slow it down for a minute and recognize we're only talking about one set of skills here. So it shouldn't be terrible when we're doing this. The homework assignment that you had for this, for the first section, it was just problem 15 is the thing that I'm asking you to turn in. And we'll definitely go through that. All the problems will have numbers. Yes, all of them will have numbers on here. Okay. And then for the second one, for section 7.5, you had 18 and 19 on these pages, and we didn't have a whole lot to do. The reason why I picked both of those is because 18 asks you for the perimeter of a shape and 19 asks you for the area. And so this basically uses the same shapes to compare them. So we can talk about both of these, but I really wanted to get to problem 15. However, Will, you talked about being sort of lost, and I respect that. That's totally fine. What I think we should do is let's continue talking about 18 and 19, looking at the actual problems that are on here. So like this is problems 18 and 19 from here, okay? And when we're talking about the shapes that we're seeing here, it shouldn't be too difficult for us to figure out what to do. These are pentagons. We have a side that clearly corresponds to a side here. AE and FK correspond, and we can even see A to E and F to K. So we can set up a similarity ratio from here to here. They've given us the perimeter and area of the larger shape. We're going to use those to find the perimeter and area of the smaller shape. Is everybody okay with this general idea right now before I get started on what it is that we should do? We've got like 8 minutes, which is plenty of time to go through some stuff. I am not by any means going to draw this. So what I'm going to do is I'm going to write big and small in terms of the things that we have here. And I'll get the information that they have given us. The big one, the side they gave us was 90. The perimeter was 381. And the area is 1944. Then the small one, they gave us a side of 60. We don't know the perimeter and we don't know the area. And those are what our two problems are. 18 is the perimeter, 19 is the area. Okay, so with that being said, I'm going to do a new share. We're going to look at my camera again, and you're going to take a chance to kind of see what I've got written down here. So this is all of the information that I've written down based upon what we just did there. Everybody okay so far? All right, cool. So first thing that you want to do is you want to set up your similarity ratio, which means we're going to start with the sides they gave us. I'm going to go big to small just because it's the way I have it in the order. So this would be 90 over 60 is my similarity ratio. Can you help me reduce that, please, and tell me what the reduced version of that would be? Gabe, you're right. It is 3 over 2. Okay, so right now, we know that we're going to be using the ratio 3 over 2 to compare things. 3 over 2 is the ratio of side to side. It is also going to be the ratio that we use when we talk about perimeters. So when I compare these two perimeters, because it's just more sides put together, 3 over 2 is going to be compared to 381 over something. We'll do that in just a second. Then, when I'm talking about the area, what I have to do is to take that 3 over 2, and I got to square the top and the bottom. So the area ratio that I'm going to be using is going to be 9 over 4, because 3 squared over 2 squared is 9 over 4. So when I do the comparison of the areas, this is the one I'm going to be using. That's the biggest point, is the difference between these two. So before I move on and start doing this stuff and setting them up, how do you guys feel about this? Everybody okay so far? All right, cool. So for problem 18, we're setting up the proportion 3 over 2 is equal to 381 over P, because we know that that is our similarity ratio from big to little. And here we're doing big perimeter over little perimeter, and that's what we're looking at here. On the side here, I'm going to do the same thing with the area as a second problem. Here we're using 9 over 4 as our base because that's the area. And we'll use 1944 over A. Now, to solve for these, I just have to cross multiply and solve. And I am looking at my time and saying, okay, I've got time to probably do at least one of them. We're going to see if I can get to both and see what I can do with something like this, but just wanted to make sure. Hang on, here we go. Okay, so when I cross multiply, I am going to get 3p is equal to 2 times 381, which is going to be 762. And that means if I divide both sides by 3, I'm going to get that 762 divided by 3 is 254. Our perimeter of the smaller shape is 254, which is nice. Now, if I do that same thing and I cross multiply for my area, the numbers are going to be a lot bigger. So we're going to get that 9a is equal to 4 times 1944, which is 7776. That's kind of fun. Divide them all by 9. Let's see if we get a nice happy whole number for this one. We do. The area is equal to 864. That's all we got to do. That's problem 18. That's problem 19. How you feeling? Awesome. I am going to swiftly shift to how we set up problem 15, because this similar shape is spectacular. And I normally don't get to these things and go, oh my God, what did I do? This is problem 15 from the first assignment. So here's what they've given you. I looked, I was like, damn, what's happening here? And here's what's happening here. So we've got A, B, C, and D. They've told you that this is 4 and that this is 12. They've marked this angle and they've marked this angle. Now, here's the thing that messed me up. I was trying to compare this triangle and this triangle. They are not similar, okay? What I want us to do for a second is to recognize angle A is a shared angle. So if I'm going to be comparing two triangles here, the two triangles that I'm trying to say are similar is triangle ABD, because that's this guy, ABD. And that's going to be similar to triangle. Now let's think. A is the same angle here. So A corresponds with A. Angle B right here is congruent to angle C. So I'm going to say AC. And then to complete that triangle, I got to go all the way up to B. So these are the two triangles that I'm going to be comparing based upon the fact that I've got two congruent angles here and two congruent angles here. Actually, sorry, this angle is congruent to itself. These are congruent to each other. So when I set this up, I'm going to draw them separately and label them. So ABD, all right, let's make that happen. This is A, this is B, and put D up here. So A, B, D, there's that triangle. All right, we know that the B is the one that's here. We know that this one's here, and AD is this side. That's going to be my 4. All right, cool. Then let's look at the bigger one. That's ACB. All right, here we go. I don't care. I'll get there. A still corresponds with A. C is the one that corresponds with B, and then we've got the B that's up here. Now, here's the part that I want to make sure that you can see. AC is the value that we know. That is 4 plus 12 or 16. The side that they both share that's going to be important for us to think about is the side AB. So I'm going to make this one X for both, okay? So right now what I want to do is if that one is X, then can you guys tell me to find, yes, I was being shot at by a TIE fighter. If you guys can help me and you look at what we have here, do you notice that the corresponding sides that we have here are a little bit different? 4 corresponds with X and X corresponds with 16, but this is the same length. So if I'm going to set this up as a proportion, I can say 4 to X is equal to X to 16. I'm taking the small to the large and the small to the large. Now when I cross multiply this, X times X is X to the second power. 16 times 4 is 64. Hey guys, do you think you could tell me what this is actually going to be equal to? Yup, it's going to be 8. Because if I take a square root of both sides of this, I could either get a positive or a negative 8. But guys, we're talking about distance, so it's all going to stay positive. It's going to be 8. So I can say that x is equal to 8 and x is equal to 8. And we're in good shape. So that's what we got. Okay? That right there is how we would solve problem 15. Now this, guys, I'm not going to lie to you. This is a beast of a problem, and I was a terrible human being for showing it to you. But I'm glad that I talked it through before we got to this. So I'm going to take a minute and stop sharing and say to all of you, does anybody have a question before I let you go? You have a quiz you have to do. You have 2 homework things that you got to finish, but I did go through kind of everything, and I recorded myself. So if you want to come back and watch it, you can. Do you still have to turn in problem 15? Hell yes, you do. Write it up. It's not fun, but the whole class around it was fun. So really, you're talking about equal portions of fun that sometimes are put in different ways. Oh, homework's fine. You'll be fine. Gonna be fine. Hey, guys, have a lovely weekend. It was good to see you. Bye, everybody.